Bienvenue, and welcome to the Open Compute European Summit. Please welcome Executive Director, Open Compute Project Foundation, Crawford.
Bienvenue, bienvenuto, bienvenido, willkommen. I love coming to Europe because there's so many ways to say welcome. And welcome to the Open Compute European Summit. You know, I think about these languages and the ability to welcome somebody into a community or into a conversation. And I think about a standard way to do this. And so standards are actually very important to me. They're very important to Open Compute. I want to start off today by telling everybody that Frank Frankowski, the chairman and president of the Open Compute Project Foundation, could not be here today, but he sends his best regards. I'm sure he's watching the live stream right now. So hello, Frank. It's good to be here. It's fantastic to see where this project started, where it's seated, and how it's grown over time. The project began in 2011 by Facebook, specifically Frank. And over this time, Frank and team has grown this project into a multinational global brand for a community dedicated to increasing the pace of innovation, increasing community-based standards so we can adopt the technologies that are important to us. So we talk a little bit about standards, we talk a little bit about innovation and the pace of innovation. So my name is Crawford, the executive director. I don't know if anybody knows the name Joe Kettinger. He was an Air Force pilot, broke the skydiving record for highest free fall in the world in the 1960s. And just a few months ago, actually, just about a year ago, a guy named Felix Baumgartner, he broke that record. And just a few days ago, Alan Eustace, senior vice president at Google, broke that record again. So we're seeing pace of innovation inside of this entire industry speed up. Now, with innovation and with the speed at which we're able to bring new technologies into reality, we have to be mindful always of the ability to differentiate that technology. And I just want to show you for a second. I call this my Band-Aid. And I carry this around wherever I go. And this allows me at least some temporary way to power the devices that I need powered. And in fact, this does not even work in Europe for me. It doesn't work here. I have a whole different version of this that allows me to plug in here. I want to take a quick second. I'd like to thank Microsoft, Intel as our platinum sponsors. I'd like to thank the rest of our sponsors, HP, Western Digital, Hive, Schneider Electric, WeWin, Stack Velocity, and a special thanks to our event sponsors, Enria and Parasoc Lake Campus. We could not do this without you. I don't know where Jean-Marie is in this in the audience, but thank you, Jean-Marie, too. Jean-Marie and Isabel from Split Desktop have been, thank you, yep. Thank you, guys. They've been critical in helping us seed this community, get the word out, and promote the benefits of open compute. So thank you. And another thank you to Goldman Sachs. If you guys aren't aware, we have a $5,000 US prize going to the hackathon winners. So after this morning keynote session, you can go pick up a hacker badge, and you can start hacking on Arduinos, some PCBs. We've got a bunch of different components for you. So pick up that badge, do some hacking, and let's win some money. And thank you, Goldman Sachs, for sponsoring the hackathon. So I talked a little bit about Frank. Frank came from a little company called Facebook. Facebook, back in 2011, started this project called Project Freedom. And this was freedom from gratuitous differentiation in the industry. They were growing at the time massively, like I'm sure they're growing massively now. They were growing very massively, very quickly, and they were having to order multiple revisions of multiple different boards from multiple different vendors, and they found when they racked this equipment, the interfaces, the protocols, all the ways to interface with the components, right? DCMI, IPMI, these protocols, they're all slightly different. It was a little hard to talk to all of those components in a standard way. So they started a project called Project Freedom. And Project Freedom was literally the freedom for them to standardize on data center infrastructure that they knew they could manage. Facebook welcomed Rackspace, Goldman Sachs, a gentleman by the name of Andy Bechtolsheim, who happens to be the father of Sun Microsystems and Arista Networks, Intel, and we expanded the mission to include, not just hyperscale environments like Facebook, but allow the next generation of technology companies to adopt the benefits and the principles and the tenets of what Open Compute was designed to do. Recently, we've added Microsoft to this. So in January of this year, Microsoft came out big with a huge announcement around OCS. And you're going to hear more from Microsoft here in a second. But you're seeing now a transformation. You have some great companies over in the exhibit hall. You've got HP there with an Open Rack. You've got Quanta there with Open Rack and the RackOX stuff. Amazing technologies, and we're seeing this pace of innovation pick up again. But what we're seeing now are standard interfaces. The adapter that I showed, that's only half the problem, right? Half the problem is the interface, what you plug it into. Does a square peg fit in a round hole? No. So there's a whole nother problem we have to solve around electricity and voltage, et cetera. But through the efforts of these great companies that are involved with the project, we have now grown this project to over 150 corporate members. And you'll see European companies on here. You'll see American companies on here. You'll see Chinese companies and Taiwanese companies on these slides. We're picking up speed, and we're really looking to leverage Europe as the next place where we increase the pace of innovation using community-based standards. So what do we do? Open Compute, as you may or may not know, is a nonprofit, which means we don't actually sell a product. We have a vision for the way things might work, and people that believe in that vision, we encourage to get involved, and we'll touch on that a little bit later. But that means we need to constantly be interfacing with our community. And this is one example of the way we interface with our community. We put on a number of different events. We put on these types of summits where, the great luminary, visionary speakers from transformative companies get on stage and talk to you about what they're doing. And then we actually have all of our projects represented here today. So you've got all of the technologies we govern. So we're out in the community. We run engineering workshops, we run these summits, we run community building days in environments where it might be new. And in fact, we've done community building days in Ireland, so we've been in Europe. And that's a way for us to sort of interface with the community in a way that lets us determine when the best time to engage that community is. And again, through the efforts of Splitted Desktop, Intel, Microsoft, HP, et cetera, this feels like the right time. I've had some great conversations with members of the French government, and it seems like there's a transformative opportunity over the next few years to really drive open innovation into the European ecosystem. So that's what we do, but what are we? We're a platform. We're a platform for the engineer to look outside of himself or herself into other companies with subject matter experts that might have a slightly different but complementary capability for an innovation. It's a place to test an idea with other smart people capable of designing things similar to what you can design. To the provider, we're a platform for introducing these types of technologies into the data center in a new way The typical model is a push process where the vendor says, this is what we're doing, and this is what you can consume, and you need to make your software work on our hardware. The model with Open Compute is completely flipped. So now it's a pull process and not a push process. You're able to say, this is my workload, this is what I need my infrastructure to do to manage that workload, and you can get exactly the hardware that you want to consume. And this is exactly what Facebook does. If you think about what Facebook does and uploading photos and communicating with your family and your friends and sharing experiences, if you think about how you do that, that ends up looking like a lot of object data. And if you look at the Open Compute rack out there with Winterfell and the Knox box, you'll see very streamlined compute nodes attached to very streamlined storage nodes. And that's how Facebook has solved their problems. So Open Compute is a way for you to manufacture your own medicine. Finally, to the customer, it's a way for you to get the technologies that are relevant to you inside of your data center. So the technologies we govern, I'm not going to go over them all. I'm actually short on time. But these are the technologies we govern. All of these projects are represented out here. So if you're technical and you want to go have technical conversations with the project leads, you can find that after the morning sessions. There's signage that will guide you to the appropriate engineering room. We've got multiple rooms depending on what area you're interested in, but those will be out in the exhibit hall ready for you. So very quickly, the industry standard for measuring data centers is this metric called PUE, and that's power usage effectiveness. And the way that the typical data center operates globally is you take your 480-volt AC off the wire, you transform that power, you step down that power, you transform that power again, you use, in most cases, coal-generated energy to cool that infrastructure. You finally get power to your rack, and you end up with an industry standard of about 1.9 PUE, which effectively says you're spending 90 cents for every watt delivered to the rack. Open Compute took a slightly different approach. They took the 480-volt, turned it into 48-volt DC. They use geographically relevant cooling technology. So in some centers, you'll see evaporative cooling and misters. In other centers, you'll see free cooling environments, like in Luleå, Sweden. And you end up with a 1.07 PUE. So ideally, technology flows directly to consumers. But somewhere along the way, suppliers got in the way of those consumers. And they started, now there's a benefit to this, and there's also a downside to this. They were able to standardize on some stuff. They were able to create alliances, and they were able to come up with standards that allowed them to sell technology in a way that it was relatively easy to consume these new technologies, and they could compete. But it also slowed down the technology. And consumers and customers and people adopting technology had to wait longer for new versions. And they no longer had the direct control of saying, this is the technology that's relevant to me. So Open Compute kind of, again, took a different approach and said, what if we enabled the suppliers to work with both the technology providers and listen to their consumers at the same time? And we came up with a pretty novel concept. Through an open source license that we've written, we now have the ability to both offer a reciprocal, which means upstream first license, and a permissive license, meaning you can take it, you can modify it, and there's no requirement to give it back to us. So we've taken this licensing approach that allows you to contribute and consume technology in an open source-like way, the same way that we adopt software technologies like OpenStack, like Linux. The other thing we've done is we've set up certification. And certification is important because unlike software, hardware can burn down your data center. And we don't want that happening. So we go through engineering nonprofits like eTree and UTSA to ensure that all of the equipment that you're adopting works and works well. So this picture is the data center logically in terms of openness. And before Open Compute, what you see in green were the things that you could adopt in a very open way, things that we took for standards, open source standards, in an open way. Through the efforts of Open Compute, one by one, we started unlocking the rest of the data center. And actually, when I first joined Open Compute, I was not sure that we would see these final two: network hardware and network software. As many of you know, there's no BIOS in standard network hardware. So getting firmware onto a box included some pretty technical steps, and most vendors were very secret about how they interfaced with their hardware. Through a combination of Broadcom contributing a Trident 2-based white box switch to the foundation, and another sponsor here, Cumulus Networks, who has a booth out there, contributed a software component called ONI, which is Open Network Install Environment. For the first time in the industry's history, you now have an open source way to lay down a software-based OS, Linux-based OS on top of your white box networking hardware, enabling you the freedom and flexibility in your network environment. So obviously, with the prediction of by 2017, every person will be wearing on average of 7 IP addresses through wearables and the Internet of Things. We have a data growth challenge. There's a slide that Frank showed in January about the amount of data that exists in 2020, and that number is 40 zettabytes of data. That's a lot of storage. And we're not going to need real-time access to all of this storage, which means we're going to need a lot of infrastructure to house cold storage, where retrieval is not, real-time retrieval is not the goal, but archiving that data is the goal. Looking to the future, the disaggregated rack. Later, you're going to hear from Intel on a new technology they're bringing to market called silicon photonics. And actually, back in January, Intel contributed the interface and the cable to silicon photonics back to Open Compute. So now you have a standard cable and a standard interface to adopt this next generation backplane technology that has bandwidth capabilities far beyond what the data center has seen prior to Intel silicon photonics. So please stay around. And make sure you're listening to that talk, because the disaggregated rack is 100% about racking capacity and not servers or racks. And then looking a little further down the road, alternative processing architectures. There's a really fundamental paradigm shift happening in the industry right now, and I've personally seen companies like Intel showing off Avaton and Atom in an open rack. And with the power savings you get through this SoC-type model and these alternative architectures, we're seeing performance increase through Moore's Law, but we're seeing energy requirements decrease by the efficiencies designed into the core tenets of these next-generation alternative architectures. And then finally, again, flexibility and choice in networking. This is going to be a huge shift. If you watch the news around Open Compute, there was some noise last week about a new big company getting involved with Open Compute, so we're excited to see them getting involved. So with that, I just want to leave you with this message of collaboration, contributions, and consumption. It takes all three of these in order to make a successful project. So after the next couple of days, which are going to be fantastic, I want to make sure that you guys are all aware that our next summit is March 10th and 11th, 2015, in Santa Clara, back in California in the US, and I hope that you guys can all join us in California in 2015. With that, I want to say thank you. I don't want to take up too much of your time,